Hello, good afternoon. Could you please confirm that you can see me, hear me, as well as you can see the presentation? Hello, could you please confirm that you can hear me, as well as you can see me, as well as you can see the presentation? Hello, could you please confirm that you can see me, you can hear me, as well as you can see the presentation? Any one of you?
Yes, sir.
Yes, sir. Okay. Is my voice clear?
Yes, sir.
Yes, sir. Okay. Great. Okay, we shall start now. Good afternoon, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department at IIT Kharagpur, and I'll be taking your this live interactive session on the course subject farm machinery. This subject is taught on the NPTEL online platform by Professor VK Tiwari, Director IIT Kharagpur. Yes. So what we'll be doing in this live interactive session, I'll be posing some of the questions based on the previous week's content in front of you. Okay. And what we have to do is you just have to answer the question based on your knowledge and using the chat box. Okay. Then we'll have a detailed discussion that what would be the correct option. Okay. So the very first question for this session is this: the type of moldboard suitable for plowing in extreme sticky soil conditions is known as general purpose type, sword or breaker type, sled type, stubble type. Okay. So based on the previous week's content, just try to answer this question. Okay. Need not that you have to be correct in the first attempt, but just try to solve it. Okay. Give your options in the comment section or in the chat box. Just try to just give the right option. Only the option can also work. Okay, if you don't want to type the full option. Yes, Varnika has answered sled type. Okay, the type of mold board suitable for plowing in extremely sticky soil conditions. Okay. Yes, Hari Krishnan has answered sled type. Okay, great. Two more people are left. Please do try to answer it. Okay, there is no penalty. Nobody will harm you. Okay, whatever option comes to your mind, you can just give the option. Okay, Mercy is saying sled type. Okay, okay, sled type. Great. Okay, let's proceed. Yes, the type of moldboard which is suitable for plowing in extremely sticky soil conditions is known as sled type. Okay, let us look at the explanation in great detail. Okay, these are some of the types of moldboard. Okay, which are available in moldboard plow. Okay, general purpose bottom. First thing. Okay, this one is general purpose moldboard. Okay, it lies in between the two extremes. All types. Okay, and is suitable for wide range of conditions, not specifically for one particular attribute, but it can be used for a lot of types, for a lot of purposes. Okay, that is why it is named as general purpose. First one. Second one was sword or breaker type. Okay, it has long and low mode with gradual twist, or the spiral is there that completely inverts the furrow slice with a minimum of breakup, thus converging the vegetative matter thoroughly. This is very useful when you have bushy conditions. Okay, or there is some type of debris on the soil. Okay, so you can just invert the soil and you can convert the vegetative matter into the manure. Okay, for that purpose your sword or breaker type bottom is useful. Okay, yeah. Third option was slat bottom. Okay, it has portions of moldboard cut out and is sometimes used extremely useful in extremely sticky soil conditions. Okay, third type of mold board. Okay, and the last option was stubble bottom. Okay, it has a relatively short and broad mold board that is curved rather abruptly near the top, resulting in a greater degree of pulverization than it is with the other types. Okay, these are four different types of mold boards and the uses. Now, just I'm trying to be a little bit interactive with you people. Okay, if you have gone through the lectures, just give this answer, that how we model the surface of a mold board. Okay, my question is very simple. These are the types of mold boards. Okay, now I have seen a mold board and I want to model it. Okay, for your understanding only, I am just asking you, just try to give the answer how I can truly design or truly create a surface of a mold board. Any idea? Anyone? You can type also if you want to unmute, and you can then you can just tell me. Based on the soil surface. Very good. Hari Krishnan is saying that based on the soil surface. I think you didn't understood the question. I just wanted to ask you that how will you model the surface of a mold board? Modeling means I want to create a design of that particular mold board. Okay, so I'll try to create some surface, then I'll try to model it, and then I'll try to do some analysis so that which type of mold board is suitable for which type of soil condition. So how to model that surface? Yes, yes. You want to answer? Then you can please answer. I was just asking you about the modeling of the surface of a mold board. Okay. So just for your information and for building curiosity, okay, we can always model the surface of a anything, not just mold board. We can model the surface of the yes based on angle of degree. Please do explain this statement. Okay, I am just explaining you. We can model the surface of a cultivator also. We can model the surface of any cutting tool, okay, as well as mold board using finite element analysis. Okay, this particular method is there. Based on this method, this is one of the methods, okay, not the absolute method. We try to model the surface of a mold board. We try to model the cutting tool, as well as we try to model a lot of different types of tools and implements. Okay, this is done in a particular software which is known as EDM. Okay, so I am assuming that most of us are researchers as well as BTech students, MTech students. Okay, so you there is always a scope for your own understanding. I am telling you that you can learn about this technique. Okay, and if you have any doubts, then you can please answer in the upcoming sessions as well as in the this session. Okay, let us proceed forward. Yeah, the most suitable mode board for plowing in extremely sticky soil conditions, as I already told you, is flat type. Okay. General purpose type, it is for average soil conditions. Okay. This one is important. Please do remember. Okay. It wouldn't be ideal for extremely sticky soil conditions. Okay. Sod or breaker type. Okay. This particular type of mold board, it is good for flipping over sod or burying the vegetation, as I already told you. Okay, if you have some debris on your soil and you want to bury that soil for improving the soil fertility, then you can always use sod or briquette type. Okay, and slat type, it is extremely useful for light and sticky soils. Okay, the slats create high pressure between the soil and the mold board, promoting a scouring effect. What do you mean by scouring? Scouring is the process of destruction of the outer layer of the soil. Okay, scouring effect. Okay, that helps break up sticky clumps and allows the soil to move more freely. Okay, free movement of soil is there because of this particular scouring effect. Okay, slat type. Okay, good. The stubble type, this type is designed for working with stubble residue, not particularly stinging conditions. Okay, so each and every type of mold board is having a particular use. Okay, we have modeled it, and how the modeling is done, that also I have told you. Okay, just for your curiosity. Okay, in the design process only we know that which type of implement or which type of cutting tool we have to use for which type of soil conditions. Okay, so that is done by finite element modeling. Okay, that was just for your own information as well as your understanding. Okay, clear? If anyone has any doubt, then please do ask me. Rest, we'll move forward. If you are clear, then please do type clear. Okay, meanwhile be responsive as far as this session is possible. Okay, clear, great. I'm assuming that everyone is clear. Okay, we'll move forward. Yeah, very simple, very easy question. Please do try to answer it. The disk angle in a standard disk plow varies in the range of 40 to 45, 50 degree, 42 to 45 degree, 15 to 25 degree, 25 to 30 degree. Please do try to answer this type of this question. Disk angle in a standard disk plow. Okay, I am talking about disk plow, and I want to know what is the disk angle. Okay, 40 to 45. Okay, great. Two people have answered it. B. Try to be as responsive as possible. This is a live interactive session for you only. Okay. Do try to clarify all your doubts if you are having. Need not to be that you are correct in the first attempt. Just do try to answer it. Okay. Disk angle. Okay. Two people have said it B. One has said C. Then another one has said A. Okay. Great. Variety of options. Yes, Abhishek Kumar, if you have any doubt, please do ask me.
No, sir, no doubt, sir.
Okay. Let's move forward. Yes, the disk angle is in the range of 42 to 45 degrees. Okay. The 40 to 50 is a broad range. Okay. And all the both options C and D are corresponding to tilt angle, not disk angle. Okay. Let us understand what are these angles. See, here you can see a disk. Okay. And if you draw a vertical plane which passes through the center of a disk, whatever the angle the disk is making, the plane of the disk is making with the vertical is known as tilt angle. And with the traversal direction, with the direction of the traversal, whatever the disk, the angle the disk is making with the horizontal axis, that is known as disk angle. These are two particular angles. Okay. So the correct option for disk angle would be 42 to 45 degrees. Okay. It is a very narrow range. How we came to that also I'll tell you. Okay. Just in a few minutes, I'll try to explain you how we came to that particular range. Okay. Just bear with me. Okay. 15 to 25 degrees. This is a range for tilt angle of the disk. Okay. As I already told you, not the disk angle. Tilt angle refers to the angle of the disk and vertical plane, whereas the disk angle is the angle between disk and the direction of travel. Very simply, I have explained here. Okay, what is tilt angle? Okay, and what is disk angle? Already, sir has explained these both the terms in the lecture, but here I am explaining once again for your own understanding in very simple terms. Okay. Then the other option was 25 to 30. It's very low. Okay, as compared for standard disk plows, we don't generally prefer this much lower disk angle. Okay, why? Because it can reduce the penetration, but at the same time it will also increase disk rotation. Okay, these two particular attributes which I have written here reduce the penetration but increase the disk rotation. I'll explain you how. Just a second, I'll just explain you. Okay. See, disk angle is this particular angle. The angle the disk is making with the direction of travel. Okay. If I'll try to just lower it, okay, what will happen? The depth of penetration will increase, will decrease. Okay. At the same time, the thrust force which is coming onto the central line, passing to the central line, and which will act on the disk, it will increase. Thereby, angular velocity will increase. Okay. Just try to visualize, you will get it. Okay, what will happen if I'll lower the disk angle? Okay, then another option was 40 to 50. It is a very broad range. Okay, when some disk flaws might fall into this range. Obviously, if 42 to 45 is an answer, 40 to 50 would have been, but the narrowest range or the correct range is 42 to 45 only. Okay, yeah, this was the explanation regarding this disk angle. Okay, any doubts in this particular thing? Then we can move forward. I'll tell you how these particular angles are calculated for a disc plow. How we come down to this particular range. It is interesting to note. Okay. If you have any doubt till yet, then please do ask. Rest we can move forward. I'll explain you how this particular disc angle we have got. Okay. Any doubts? Clear, not clear up till yet? Abhishek Kumar, your hand is raised. If you want to ask anything, please do ask me. Clear? Okay. Yes, your hand is raised again. If you want to ask anything, please do ask me. At any point of time, any one of you can unmute and ask. Otherwise, you can type the in the comment section. Okay. I am open for any type of discussion. Okay. Yeah. Now you just see this particular figure. Okay. Here, I'll zoom in for you. This is soil bin. Okay. Just a second. Yeah. This is soil bin. Left figure. Okay. This is soil bin. Here, what is happening? This particular is thing which is known as soil bin carriage. This particular machine is there and it is run in this particular soil bin. So in the soil bin, different types of soil conditions are maintained. Okay. Heavy soil, medium soil, clay soil, any type of soil we can input. Okay. Here we are at IIT Kharagpur, we are having two particular this soil bins. Okay. So similar to that, I am showing you this picture. This particular thing is known as soil bin. Okay. Inside this particular machine is there, or this particular setup is there, which is known as soil bin carriage. Okay. Here, I want you to just see this. These are particular wheels. Four wheels are there. Okay. Four wheels are there, which will guide through this particular setup. Okay. And this particular is power unit. This particular unit is power unit. Okay. And here, this particular screw, which I'm just putting an arrow to it. This is lead screw. Okay. This particular screw is known as lead screw. It is used to lower down or increase the height of this particular carriage. Okay. This is a lead screw, the black one. Okay. This one is your motor. Just try to see this, visualize. Okay. This is another control box. Okay. And the most important thing which I want to show you is this particular thing here. I'm just creating a box. Just see it here. Okay. Yeah. Here I have placed one disk. Okay. And disk is supported by this platform. And this particular platform is just connected to this rod. Okay. What this setup is? This setup is provided so that you can change the disk angle. You can change the tilt angle of the disk, and you can mechanically actuate the disk in the soil bin so that you can calculate what are the forces. For force calculation, force transducers are fitted. Okay. Force transducers. What are those? Those are strain gauges put in Wheatstone bridge. Simply, you can understand. The Wheatstone bridge is a concept you must have read it in class 12th. Okay. Four resistors when they are connected in this form. I'm just giving you the concept in short. Okay. In this particular manner. Okay. Like this. R1, R1, R2, R3, and R4. They have to be connected in this particular diamond shape. Okay. And the ratio has to be maintained such that R1 by R4 is equal to R2 by R3. Okay. So when in this particular configuration, which is known as Wheatstone bridge, any amount of force is induced, then as you know, R is rho A by L. Okay. Then what happens? The resistance of the Wheatstone bridge changes. So when resistance changes, then what happens? The current changes, and we can calibrate this particular change of the current with load. Okay. So this is the basic principle of the working of force transducer. It is nothing but a four strain gauges put in a Wheatstone bridge. Okay. So these particular force transducers are used to measure the force. whatever is the amount of force, whatever is the amount of draft and vertical force, side force, each and every force we can calculate using force transducer, okay, which are fitted on this particular setup. Okay, so lowering the height or increasing the height, depth of penetration, that is also available. Changing the angle is also available, because here you can see the disc, it is joint here only rigidly. Okay, rest of the angles we can very easily change by just loosening the nuts and bolts and tightening them to the correct amount of angle. Okay, so here in this particular setup we just perform the test. Okay, and what here another figure is there. Okay, here we have done it for single type disc furrow. Okay, and loading also here, you can see. Okay, very nicely they have depicted here how disc angle and tilt angle we can just change. Okay, and we can measure the amount of forces. Okay, after performing the test, after running the soil bin, after running the soil bin carriage, okay, for in the soil bin for a particular configuration many number of times, you will get these type of plots. Okay, so here we have measured vertical force, dart force, as well as the side force. Okay, here you can see in figure A. Okay, force is there on the y-axis, disk angle is there in the x-axis. Force is there in the y-axis in the second figure, as well as tilt angle is there in the horizontal axis. Okay, so each of the force we have just calculated. Okay, so whatever the disk angle we want to keep, we will keep it in such form and manner that the draft force is maximum and the parasitic forces, the vertical force as well as the side force, they should be minimum. Okay, so that particular criteria we will take, and then we can decide what is the disk angle and what is the tilt angle. Okay, similar to that, this is the change of the vertical force, change of the draft force, change of the uh, what I think yeah, vertical force, dart force, and the side force depending on the vertical load. Okay, what is the amount of vertical load which I am increasing, as well as what is the change in the force which I am able to get. Don't go much deeper into this, but just try to understand up to this level. Okay, this is important for your examination point of view, as well as for your understanding. If you are into the research, then you can go for this particular analysis also, change in the force. Okay, that will give you more insight regarding how the vertical load can be increased. If you know this particular attribute, then you can go for designing of the disk harrow, disk plow also. Okay, this is somewhat advanced. Okay, we deal with it in masters. Okay, yes. Okay, clear up to this particular point? Any doubts, anybody, regarding the soil bin, soil carriage? Yes, Pooja, anything you want to ask?
Sir,
Sir,
disc angle
disk
mainly
angle mainly
influence the
influence the
width of cut
width
or
of cut
depth
or
of cut,
depth
sir.
of cut, sir. Okay, great. See, in this particular figure, okay, disk angle is the angle which is made by the horizontal axis with the plane of the disk. Okay, try to just visualize. Okay, so while I'll be changing the disk angle, I'll be changing the width of cut primarily. Okay. While I'll be changing tilt angle, I'll be changing the depth of penetration primarily. But these two attributes are related with each other. So a study has to be performed regarding that. But primarily, yes, that is very clear that while I'll change the disk angle, I'll be changing the width of cut. But when I'll be changing the tilt angle, I'll be primarily dealing with the depth of penetration. Okay, just try to visualize this from this particular figure. Okay,
Okay, sir.
okay, sir. Okay, clear?
Yes, sir.
Yes, sir. Okay, okay, great. Any doubts, anybody? Clear, not clear? Everything clear? Feeling boring? Want to speed up? Anything? Clear? No response. What happened? Clear. Great. Okay. Okay. Great. Let's move forward. Okay. Yeah, the offset disk harrow is especially well suited for working under stony field, sticky field, sandy field, or orchard field. Four options are there. Okay, just try to answer it based on your knowledge. A lot of people have joined. Oh, yes, yes, please, Abhishek Kumar. Please do try to answer this question, Abhishek Kumar. If
D.
yes,
Option is D.
Option is D.
Yes.
Yes.
okay. You can just type it. Okay. A lot of people have joined, so I'll not be able to note. You please just type it. Okay.
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 Okay. A lot of new people have joined. I'll be posting questions based on the previous week's content. Please do try to answer it using the comment box. Okay, chat box. Yes, Pooja wants to say something. Okay, two people are saying D. Okay, I'll write here D option from Abhishek. Okay. Okay. A lot of people are saying D. Great. Nice. This time we are seeing a clear majority up till yet. Anyone wants to differ from option D? Okay, D. Offset disk harrow. Yes, regarding the notes of this particular class as well as the recordings, they'll be available for in this Google Drive link. Okay, so do just make a note of it. Okay, I think you can see it. I have pinned it already. Okay, the recording of this particular session. Okay, as well as the notes, they will be available on this Google Drive link. You can always go for them before having the exam. Okay, before the exam or whenever you want to revise this particular questions, then you can go for them. Okay, yes, yeah, the correct option would be D. Okay, the offset disk harrow is especially well suited for working under orchard field. Okay, see here, three types of disk harrow I have shown here. Okay, first option is single acting disk harrow. Okay, don't go for the numbering, it should have been A. Here I have written B by mistake. Okay, the another one is offset disk harrow, and this one is tandem or double offset disk harrow. Try to visualize. Okay, single acting disk harrow will be moving. How it will be moving? It will be attached to the tractor, then it will be moving in a particular direction. Okay, this particular offset disk harrow, why it is extremely useful for orchard condition? The reason is that it will the line of pull would not be in a straight line. Okay, so it has a high maneuverability. Okay, so it can just move around the trees. This is the reason we consider offset disk harrow for orchards. Okay, offset disk harrow, just we can see here, offset disk harrow is an agricultural implement that is used to till the soil where crops are planted. Obviously all the harrows are for this particular purpose only. Consists of Series of concave metal discs arranged in two or more rows. Okay, I already showed you. These discs cut into the soil, breaking it up and turning it over. Okay, offset disc harrow. Okay, suitability for different field conditions. Stony field. Okay, I have analyzed all the options for you. Okay, just after this class or during this class also, just try to go through how you can just analyze. Okay, first condition was stony field. What is the challenge? Stony field can damage the disc of the harrow and reduce its effectiveness. That is why disc harrow is not a particular option. Okay, stones can cause the wear and tear. Okay, it's harrow, not plow. Okay, you might ask me that disc plow is generally suited for stony conditions. Okay, both the implements have different designs. Okay, so it's harrow. It has lesser diameter disc. Okay, as compared to disc plow. Okay, diameter of the disc plow in is large, as well as the strength of the material is also large. Okay, stones can cause wear and tear. That is why we are not just going for stony field conditions. Okay, then another option was sticky field. Okay, sticky fields are often characterized by heavy clay soil. Okay, and since the number of discs are just large. Okay, up to 6, 7, 8, 9, 10. Okay, as well as the spacing is also less. Okay, so it can cause the disc to clog and reduce its effectiveness. Okay, soil may stick to the disc, making it difficult to have a clean cut. Okay, that is why we are not going for sticky fields. Okay, another option was sandy field. Okay, sandy fields are generally easier to work. Okay, with when the soil is loose and it cannot cause much wear and tear to the equipment. However, sandy soil may not offer enough resistance to properly utilize the weight. Why I am carrying this particular weight? Okay, uh, in the sandy soil condition I will be able to easily move. Okay, so enough resistance will not be provided, so the amount of weight which I am carrying, it won't be useful enough. That is the reason I can go for, with the disc harrow in the sandy soil, but I don't go for it. Okay. Another last option was orchard field. Yes, the offset disc harrow is primarily well suited for this particular field condition. Okay, they require careful maneuver around the trees and maintaining the soil without damaging the roots. Okay, equipment must be precise and adaptable. That is why I'm going for disc harrow. Okay, yeah. What advantages I am getting? Maneuverability. Yes, obviously I'll get it. Okay. Versatility. Yes, they can handle different soil conditions within the orchard. Okay, effective soil management will happen. Okay, proper aeration, moisture retention, everything will happen. Okay, and soil compaction will automatically be reduced because I am going with the disc harrow. Okay, this is the thing. Yeah, the more appropriate explanation or the summary of whatever these two slides say is given in this slide. Okay, offset disc harrow with two gangs in tandem. Okay, two gangs in tandem means having an offset. Okay, they are capable of being offset to either side of the central line of the pole. This is the reason. Okay, the central line of the pole, which will pass through the center of resistance. Okay, so the both the discs they are capable, both the gangs they are capable of being at either of the side. Okay, so one side behind the other. Okay, the width covered by these type of harrows ranges from 4 feet to 30 feet. Okay, soil is thrown in both the directions. Okay, of the offset disc harrow. Okay, it is very useful in orchards and gardens. Okay, it travels left or right of the tractor. Okay, important for you to understand. Line of pull is not in the middle. That is why it is known as offset disc harrow. Okay. Offset disc harrow is based on the principle that the side thrust against the front gang is opposed by the side thrust of the rear gang. This is important. Okay. Gangs are arranged in suitable angles so that both the thrusts are counterbalanced. Okay. This is particularly important while designing an offset disc harrow. Okay. This is particularly important while designing an offset disk hero. Okay, this particular last point. Okay, basic principle you have to always remember. This is the thing. This is the explanation from my side. Any doubts, anybody? Please do ask me. Each of the option I have analyzed, not just the correct option. I've analyzed all the options. Okay, A, B, C, and D, and I have told you why offset disk hero is best suited for arthritis. Okay. Any doubts? Anybody? Clear? Not clear? No response. Clear? Not clear? Any doubt? Anything? Clear. Okay. Clear. Good. Clear. Great. I think in the afternoon, most of the people have had a great lunch. That is why people are feeling sleepy. Is if it is the case, then you can tell me. I'll adjust my pace accordingly. I'll try to explain it once again if you are feeling sleepy. Okay. Good. Now moving towards our next question. Which type of blade is most preferable for operating the rotavator in trashy conditions? Okay. This question is again related to design. Okay. So think accordingly and then try to answer. Options are twisted blade, straight blade, curved blade, and L-type blade. Okay. Do try to think first, then try to answer. Okay. Take your time, but try to answer it correctly. Yes, Varnika has answered. I think D. Yes, great. D. Okay. Okay, two people have answered it D. You try to answer it. Yeah, D. Great. Don't feel shy in answering the question. Okay, nobody is going to judge you. Please do try to answer. And if you want, you can write a short explanation also. I'll be very happy to see it. Okay. There is no penalty in giving wrong answer. Just try to give your opinion. Okay. Based on the previous week's content, I am just giving you the questions as well as the explanations. Okay. Yes, Pooja is saying C. If she'll just give a short explanation, very useful, or I'll be very happy to have a healthy discussion. Yes, Abhishek is also saying C. Okay. Those who are saying D, they can also give a short explanation. Those who are saying C, they can also give a short explanation. Okay. Meanwhile, we can have discussion. Yes, please unmute yourself. Whomsoever wants to say anything, he can say or she can say. Okay, Hari Krishnan is saying D. Great. So we are in option C is losing majority just by one vote. 3-2 is the ratio. No, the ratio is 4:2. Okay. Why D? Why C? Anybody? Or why not A and B? What is the problem with twisted blade and straight blade? Why not to go for them? What is the problem? The conditions are trashy, means trash is there. The conditions, the field conditions are not smooth. Yeah, actually they cut weeds pretty much. Okay, your option was D. Okay, so they cut weeds pretty much. Okay, great. L type blades are helpful in cutting down weeds. Okay, great, nice. Okay, great. I think we should move forward. Yes, do whomsoever answered D, they are absolutely correct. Indeed, the explanation is also correct. L-type blades are helpful in cutting down the weeds. That is why we will go for option D. Why not for option C? This is a particular question which you can ask me as well as you can ask yourself. Okay, just I'll answer it. Okay, make a C here. Okay, this is a blade. I'll make a C and I'll make a L. Okay, this will be the profile for the blade. Okay, C will be somewhat like this. I'll made the curvature somewhat more. Okay, but it will be somewhat like that only. Okay, I made it slightly more. Okay, no problem. C type blade as well as L type blade. Okay, the center of stress in C type blade would be at this place. Center of stress, or the point where the entire uh, force would be the force distribution would be highest. That would be this place. And in case type L type blade, it would be at this place. Do you agree? The force concentration in the entire profile, okay, it will be highest at the joint in case of C type, and at the L type it would be at the junction. I think you can very easily visualize it. Okay, if you'll go for modeling, then same result you will see. Okay, I'm telling you in advance. Okay, so in case of C type blade, the failure chances are slightly higher. Okay, in case of L type blade, if you will just see it, the thickness of the blade is the maximum at this particular place which I have highlighted. Okay, I made a circle in both the blades. If you will try to just see the blade, okay, that thickness would be highest where I have circled. Okay, why is it so? Sometimes material is also changed because the force acting would be highest when the cutting tool will interact with the soil condition. The force location would be highest at this particular highlighted points. Okay, so the chances of failure when the soil condition is trashy or it is somewhat rough, okay, chances of failure would be highest, would be slightly higher in case of C type blade. Otherwise, we can go for C type blade, okay, or curved blade, okay. But if you are going for twisted blade, the draft would be somewhat higher. Okay, twisted blade can also work. Straight blade, it is having the highest possibility of failing in case of trashy soils. Okay. Let's move forward. Look at the explanation. Twisted blade, while twisted blades can offer good mixing and good penetration. Okay. They are not ideal for trashy condition. The twist can catch the debris. Potentially, they can cause blockages. Okay. Sometimes you must have seen also while the rotavator is operating. Straight blade, straight blades are good for general purpose tilling. Yeah, they are good. As far as the cost is concerned, they are slightly on the lower side also. Okay, but lack the aggressiveness that is needed to cut through heavy trash. Okay, then you go for curved blade. Curved blades offer some improvement over straight blades in terms of penetration, but they might still struggle with significant amount of trash. Okay, the section is mainly concerned for it. Okay, what there I have drawn C type section. Curved blades, they come in different types of sections. So based on the section only, I can say that will the trash or the soil mass that will get struck or not. Okay. Then your fourth option was L type blade. Yes, L types are specifically designed for handling trashy conditions. Okay. See there the profile. If you see the trash cannot get accumulated while the rotavator is operating. Okay. The L shape provides a good chopping action that helps break down debris while also offering good soil penetration. Okay. That makes them ideal for tilling land with significant amounts of crop residue, weeds, or other organic matter. That is why my option would be option D. Okay. See, here I have given you the detailed explanation. Okay. This is a rotary tiller. Okay. Fitted with it is self-propelled tiller which is fitted with rotavator. It's a hybrid machine. Okay, it's from a research paper. Just try to see it. Okay, so here the C figure in this particular figure, this type of blade is known as L-type blade. Okay, and this particular thing which is there is in B figure. This is the diagram of the machine. Okay, here the blades are fitted. Okay, so different types of blades we can always change using the nuts and bolts. They are only tightened. Okay. Yes. So here for different types of soil conditions, medium, high, low. In the B figure, try to see it. Same setup is there. A soil bin is there. Okay. And this type of rolling structure they have made. This particular motor is AC motor. Okay. It's a high torque motor. Sometimes no, based on this configuration, I cannot tell whether it is AC or DC, but it would be high torque motor. Okay. Generally, we go for high torque motor because it won't be getting struck in between. Okay. The draft will change quickly. Okay. So that is why we are going for uh, high torque motor. Okay. We have provided in this particular figure, try to visualize high speed camera we have provided computer, then thread shaft is there, tool carriage is there. This particular angle iron frame is known as tool carriage. Okay, lighting is there, rotor flange is there, winch cable is there. Why I have made this particular setup? Because I want to change the type of the blade and I want to visualize that which type of blade is throwing the soil in which direction, as well as I want to measure parameters. Why I just try to show you so that you can just visualize that how things are happening in real. Okay, it's not just for your passing the course or just understanding. I want that you should understand the things in little detail. Okay, in depth, so that when you become researchers or you go in higher studies or even you go for any engineering job, you can always think that how real application problems they can be dealt. That is why with each and every question I try to make you visualize things. Okay, it must have come to your mind that A, B, C, and D, these are four are the options. But at the back, you should always think that why A, B, and C cannot be the correct option. Why D is the option. That is why after each and every question, I am trying to make you visualize. Okay. So this particular setup I have made. Okay. Now we'll move forward. Just a second. Yes. Yeah. So in this particular research, they have dealt with three blades. Okay, conventional, half width, straight. Okay, four conventional blades they have tested. Okay, then four medium blades they have tested. Then four straight blades they have tested, and they are up to the visualization of how the soil is getting cut. Okay, this is the main idea. Similarly, this type of combination they have also used, that if you go for straight, then to straight, then is combination. Okay. Similarly, you can also think for it that what will happen if I'll mix L type with the straight type. Okay. So that is research point of view. Okay. See here from the high speed camera, we are able to visualize. We are able to see that a rotavator when it is rotated or when it cuts the soil, then in which direction I am getting the soil movement. Okay. After that, I'll be able to obtain some results. Like in this particular figure, they have obtained the results. Like blade operating depth, they have obtained blade. They have changed the operating depth and they have got three particular attributes: furrow backfill, optimum cloud, and volume of soil disturbance. Furrow backfill, it is measured in kg per meter. Okay, just it's a technical term. Please try to understand it. It's the percentage of the untilled soil retained in the furrow after strip tillage. Okay, and it is calculated by the dry weight of the tilled soil that is collected from inside the 500 furrow section. Okay, furrow backfill. Okay, percentage of the untilled soil retained in the furrow, that is furrow backfill. So this will give you a slight idea that the blade configuration which is having minimum furrow backfill, that would be the most useful one. Okay. Similarly, clod diameter, we try to measure that the amount of 1 to 20 clods retained in the furrow soil. Okay. So for some particular crops, a particular diameter of the clod would be more useful. So the configuration can be selected accordingly. Okay. Then volume of soil disturbance, that is measured using the sand replacement method. Okay. This is particular method when the soil is when the apparatus is passed. After that, the removed soil, it is filled with sand, and the sand is again removed and the volume is measured. Okay, that is the volume of soil disturbance or the furrow volume. Okay, so higher it will be, the disturbance would be on the higher side. Okay, so based on this particular configuration checking, I can get in which type of soil condition uh, which type of blade configuration would be the most suitable. Okay, clear? Yes, yes, please do ask me. Somebody just raised hand. Yeah, Varnika raised her hand. Please do ask me. Any doubts? Anybody, anytime you can ask me. Okay. Any doubts? Clear? Not clear? Want to move forward? You want to ask something? Please do answer me. Clear. Okay. Great. The application in this particular course uh, for any particular topic is straightforward only. Okay. For exam point of view, directly go for the explanation. But how I reach to that explanation, that I am explaining you through various research papers. These are all the research papers. So as you don't get bored also, and your knowledge is enhanced comprehensively. Okay. You yourself can design such experiments. You yourself can reach to the conclusions in a scientific manner. That is what my intention is. Okay. That is why I am explaining you each and everything. If you at any point of time you are having any doubt, then you can please ask me. Okay. Yes. Only for Varnika it is clear. For rest other people, yes. For Hari Krishnan it is clear. Anybody else? Yes, yes, clear. Great, great. Please do write these type of comments. Okay, continuously. I also get encouraged that it is getting clear to you. Okay. Yes. Let us move forward. Yes, the advantage of reversible mode plow as compared to a one-way plow is to make back furrow, make dead furrow, make both back and dead furrow, not make any back or dead furrow. Yes, this is the fifth question. Please do try to answer this question. The advantage of a reversible mode plow as compared to a one-way plow is to make back furrow, make dead furrow, make both back and dead furrow, and not make any back or dead furrow. If you know the meaning of furrow, then you can very easily answer it. Okay. Yes. People are saying D. Great. Very nice. Okay. 3 people have answered it D. If at any point of time anybody is having any doubt, then please do ask me. Okay. Don't feel shy. At the same point, do try to interact. Okay. As actively as possible. Yes. One option has come as A. Good. Make back furrow. Good. Great. Okay. Yes, A. Great. I say good in both the cases. When the option is correct, also I say good. If the option is incorrect, also, then also I say good. Okay. So don't get swayed away. Use your brain. Okay. Use your knowledge. Don't be like that. I am saying good, then you change the option. Okay. Think before you can answer. Before you answer. Okay. Yes. Okay, great. Dawn of the Dawn has answered D. Please, Dawn of the Dawn, please introduce yourself. Rest of the people are having names. I can call out them. But Dawn of the Dawn, please tell me your real name. I think you also don't want to be called as Dawn of the Dawn. Great. Nice name. Mohammad Jamil. Okay, great. Now I'll address you accordingly. Great. Dawn of Dawn. Harish is saying, great. Great. D. Okay. D and A. Both options are there with people. Nobody wants to make dead furrow. Nobody wants to make both back and dead furrow. Okay. Great. So, Mohammed, what things you have done in your life which made you Dawn of Dawn? If you want to just tell me, I'll be very curious to know about why such a name, Dawn of Dawn. It's an interesting one. I'm just asking for my own curiosity. Sir, just I like the word Dawn. Okay, great. Okay, nice. Okay. So two major options are there, option A and option D. Okay. A won't be correct, D would be correct. Not to make any back or dead furrow. Yes. Because it throws soil in same direction. Yes. Okay. Now I have to check which option you have chosen. Just a second. Uh yes, yes, yes. Because it throws the soil in the same direction. Yes. Great. The advantage, okay, just a second. I haven't highlighted it. Okay. The advantage of a reversible mode plow is compared to one way plow is not to make any back or dead furrow. Okay. What is a back furrow? This is the ridge of the soil which is created at the edge of the field when a one way plow completes a pass. Okay. Just 1 second, I'll show you it in the image. For the time being, just remember this keyword, okay? Edge of the field, okay? Just a second, I'll highlight it. Ridge of the soil, okay, which is created at the edge of the field when a one-way plow completes a pass, okay? And dead furrow, this is the trench left at the center of the field, okay? One is at the edge of the field and another one is at the center of the field. Center of the field, okay? When a where two one-way plow passes, okay, means one pass will interact with another pass. One will be in one direction, another one would be in another direction, because with one-way plow you have to go in the same direction by either you can reverse, okay. First option is that if you want to move, first of all we have to always move in the same direction. Why we have to do it? Because the slope of the field should be uniform, okay. It should not be like that it is having trenches in between, okay. what will happen? This when the farmer will irrigate the field, then if trenches are present, then the accumulation of water will take place. Okay, that is why the slope of the field has to be uniform. It has to be in one direction only. Okay, that is why when we are operating, when we are tilling our field with one way plow, we have to reverse. Okay, okay, and in case of reversible plow, the plow itself reverses. Okay, it will throw the soil in the same direction, so there is no need to reverse the tractor itself. Okay, so dead furrow is created when opposite, when a one way plow, it uh, traverses in the opposite direction. Okay, one from forward direction, then another one you can see it as backward direction. So two types of furrows are there, back furrow and dead furrow, and they both are eliminated by the application of reversible moldboard plow, because it is having an hydraulic system which reverses the entire moldboard plow setup itself using hydraulic power of the tractor. Okay. One-way plow requires multiple passes while altering the direction, as I already told you, resulting in back furrows on the edges and dead furrows in the center. Okay, this can disrupt the drainage and affect the planting uniformity. Reversible moldboard plow has blades that can be flipped. Okay, using the hydraulic system of the tractor to turn the soil in either of the direction, eliminates the need for multiple passes and avoids creating back furrows and dead furrows. Both the furrows are eliminated, leads to a more uniform and level field surface, improving drainage and seedbed preparation. Okay, this is the thing. Yes, in this figure, it is very clear how dead furrow is created, and between two back furrows, there will be always a dead furrow. Okay, this particular figure is just applicable for one-way plow. Okay, in when I am tilling my field with a reversible moldboard plow, then both the furrows are eliminated. But when I am tilling my field with one-way plow, then firstly, in the same direction, one direction back furrow would be created, and between two back furrows, since the direction is opposite, a dead furrow would be created. Okay. Just after this class, okay, go through my notes, try to just visualize, okay, this particular question. Okay. Clear? Anybody having any doubt? How this particular two back furrows, that furrows, they are eliminated by using reversible moldboard plow, because the plow is just reverse. Okay. The direction of traversal is not reversed. Yes, Abhishek Kumar, please do ask me. Yes. Yes, Abhishek Kumar, please do ask me if you are having any doubt. I'm waiting for you.
Yes, my question is that when the back furrow and dead furrow is formed in the field,
Yes.
when you flying from center to outside
Yes.
or outside to center,
In
I
both
am
the
not
cases.
understand this concept, sir.
Okay. I'll explain you once
Yes,
more.
yes.
Okay. See, two particular methods are there in case, as you told. One is from, yes, another doubt. Sir, I have doubts about 25 to 30-degree disc angle. Okay, I'll revisit it. Just let me just answer Abhishek's question first. Okay. In both the cases, okay, whether I am plowing the field from center to side, or whether I am plowing the field from side to center, the furrow is getting created because of the tilling by the field with a one-way plow. Okay, it is not the method of tilling which is creating the uh, this dead furrow as well as the back furrow. It is getting created because of uh, plow. Okay, because my plow is one-way plow. Okay, when I'll just move my one-way plow from one direction to another direction, then I have to reverse it. Okay, I have to manually either reverse the plow. It is not feasible, so we reverse the tractor. So because of that only, two particular ridges, they are getting created First one is known as back furrow, another one is known as dead furrow. See, when you will see the operation yourself in the field, then at immediately you will be able to visualize. Here I am not able to show you the actual field operation, but in your theory classes, okay, in your practical classes, you will be shown. At that time, you just see that how a one-way plow is tilling the soil and how a reversible moldboard plow is tilling the soil. What is the difference? Okay, the amount, the soil which is getting thrown, okay, that interacts with the soil which is getting thrown from the reverse direction. Okay, so that creates the furrow. Okay, and between two back furrows there will be a dead furrow always. Okay, this particular furrow that will hinder the flow of the water. Okay, so it is not suited. That is why we have gone for reversible moldboard plow. The costing is on a bit higher side, but that ultimately results increase in the productivity. Okay, I know that it is a slightly difficult concept to understand. I'm just saying that when in your practical classes, you just try to see that how our plow is running. Okay, then you will be automatically able to visualize. That is why I have given you a top view. Okay, in the top view you can see that between two back furrows the dead furrow would be always present. Okay, I know that it is difficult to visualize, but I am giving you a simple advice that you just try to see it in the real fields. I hope that if the facility is even not available at your college, then you can just visit some fields. Okay, at the time of plowing, then your this concept would be 100% clear. Okay, clear.
Yes,
Still,
clear.
if you clear, great.
Yes, yes.
Okay, okay, clear. Still, if you are having any doubt, just visit some field once. Okay, your concept would be 100% clear. Any farmer, you talk to any farmer, okay, he will be able to give you the entire explanation correctly. Here something is there which I cannot just show you. Okay, even though I can click the photos also, that see this is that dead furrow, this is back furrow, but it won't help you, because visualization sometimes requires visiting the field. Okay, for the time being just go with it. Okay, go with the explanation as well as go with the theory part, but the real application that you can always go in the field. Okay, sincere advice from my side. As far as visualization is concerned, in the every question I have provided you the research papers also for this particular purpose only, so that your explanation is wholesome. But in this this particular question, the soil condition, if I'll take the photograph from the top view, it will be same only. Okay, this is a thing of visualization. Okay, yes. Sir, I have doubts about the 25 to 30 degree disc angle. Okay, disc angle is 42 to 45 degree. It is not 25 to 30 degree. Tilt angle is 15 to 30 degree. Okay, I already told you. I think you want to go for this question. Okay, disk angle is 42 to 45 degree. Okay, tilt angle is 15 to 20 degree, and I explained you why I am keeping this particular range also. Okay, using this soil bin and soil bin carriage example. If any specific doubt is there, then please do ask me. Okay, rest we can move forward.
Sir, that 25 to 30 degree disc angle,
Yes,
it will
yes.
increase the depth of angle it's given, sir, in slide. That's fine.
Yes, a 25 to 30 degree disc angle. Yes, a lower angle. See, 42 to 45 degrees on a higher side. So first point is that this 25 to 30 is on a lower side. A lower angle can reduce penetration but increase disc rotation. So you are having doubt how this is happening, or you want some you want to say that it will not happen. What's the explanation from your side? First tell me.
Sir, actually means it will not reduce the penetration, but it will
Okay.
only decrease the width of cut, I am thinking, sir.
Very good. Very nice. I absolutely admire your visualization. First thing is this. Okay. I congratulate you for this. Okay. Now I'll tell you how things are happening. Okay. See, both the angles are connected. First of all, try to understand it. Okay. If I'll be changing my disk angle, my tilt angle will also change. Do you agree or not?
Yes, sir.
Why you agree? It will not happen on its own. We keep it. Okay. Just try to understand it. Here, if you are seeing, are you able to visualize in figure second? Okay. Disk angle is also there. A
Yes,
tilt
sir.
angle is also there. From the horizontal angle is maintained. Okay. And from the vertical an angle is getting maintained. Okay. And passing through the center of the disk. Just draw a line. Okay. Then you would be able to visualize what is my tilt angle and what is my disk angle. Okay. Now, if I am going for a lower disk angle, okay, lowering the disk angle means what is happening with the direction of the traveling. I am slightly, I'll just draw it. Okay. First, the disk angle was somewhat like this. Okay. This is condition number A. And after that, I went to a slightly lower disk angle. Okay. These are my two particular things. Okay. Here, if in this figure you can see the disk angle is somewhat close to 45 degree only. Okay. From the direction of the traversal, it is close to 45 degree. And what I am saying that a lower disk angle can reduce the penetration but increase the disk rotation. Okay. First of all, if I am lowering the disk angle, then the thrust force which will act on the plane of the disk will increase. It will increase the disk of the increase the rotation of the disk. Do you agree or not? For the second point. Yes, yes. I am just asking from you. Are you clear about this? That when I am lowering the disk angle, then the rotation will increase. If this point is clear, then I'll tell you the first part.
Yes, sir.
Yes, you agree, right? That lowering the disk angle will increase the disk rotation. Okay. It is very easy to visualize. Okay. Now what will happen when I lower the disk angle and the rotation of the disk is increasing? It will increase violently. Then stress concentration would be there on the main point, main center of the disk. Okay. So for bearing with it, I'll have to change the tilt angle. So penetration mainly it is influenced by tilt angle, but when I'm lowering my disk angle, so in order to counter it, I'll change my disk angle, tilt angle also. I'll try to straighten it. Okay, try to change this particular angle. Okay, this one in order to balance. Okay. If the disk will spin so much violently, then what will happen? Stress concentration will be there on this region as well as this particular region. Okay, at the edge of the disk. So your explanation, your doubt is 100% correct. Okay, the change in the penetration is happening because I am changing the tilt angle. It is not because I have changed the disk angle. Okay, still it is there. Lower disk angle. Okay, lower disk angle will increase the disk rotation, but in order to counteract it, I'll change the disk angle. I'll reduce my tilt angle to minimize the stress concentration. Okay, so this particular thing, reducing the penetration, that is happening because of change in tilt angle. Okay, and this particular thing, increase in the disk rotation, it is happening because of change in disk angle. Okay, see, angles, they will not get changed on their own because I am changing one angle. Then as a causative effect of that, I have to change another angle in order to balance out the system. I appreciate your doubt. Your doubt was indeed very good. It must have helped us all. Okay. Still, you are having any doubt, then please do ask me. Or if it is clear, then please tell me. Okay. Clear? Great. Please do continue this spirit till the end. Okay. Do ask me as many doubts as possible. Don't let me jump to next slide till you are clear. Okay. I appreciate the spirit of both the people whom have asked me doubts. Okay. Yes. In the next class, I'll try to bring something regarding this thing. I have seen the field, so I can visualize, but I have to make you visualize. That is a challenge. Okay. Yes. Regarding this, if I get something, I'll just mark it a star. Then I'll bring it in for you. Back furrow and dead furrow. Okay. I'll go through some research papers and I'll see that how they are visualizing back furrow and dead furrow. Then I'll go through it. Okay. Just I'll see to it. Okay. Yes. Yes. Very interesting. Next question. The attachment used to cut furrow slice vertically from the land ahead of the plow bottom is known as jointer, coulter, cutting edge, none of the above. I appreciate that you are asking doubts. It gives me that the feeling that you are listening. Very nice. Yes. The attachment used to cut furrow slice vertically from the land ahead of the plow bottom is known as jointer, coulter, cutting edge, none of the above. Please do answer it. Straightforward question, straightforward explanation also. If you know it, you know it. If you don't know it, you can guess. Yes, B, A, C. Yes. Somebody can say D also. It would be in great rhythm. Okay, Coulter. Good. Majority is slightly building for option number B. Coulter. Good. Don't go with my words. Okay. Use your knowledge in answering the questions. If I am saying some option is good, doesn't mean it is correct. Okay. If it is incorrect, also, I am just saying good for your effort which you are putting. Okay. Yes. Meanwhile, if you want to change the option also, that facility is also available. Okay. Don't feel shy. This is just a practice session for you people. Okay. Okay. Option number D. None of the above. Then what you call it, please tell me. Okay. If you are having any idea you want to interact, then you can just tell me. Okay. Then what it is called, you can just ask, tell me according to you. D, sir. Okay. Don't say like it that it is known as sir. It is not known as sir. I just asked you that if the attachment is not called as jointer, coulter, or cutting edge, you are saying none of the above, then what it is called? And you have typed in sir. It is not known as sir. Sir is a word for respect. not for the attachment. Okay, let's move forward. Yes, the attachment which is used to cut furrow slice vertically from the land. Okay, ahead of the plow bottom is known as coulter. Here in this figure, okay, you can just see it. This particular, this one, I'll just mark it. Okay, here this particular thing is known as jointer. Okay, jointer in the moldboard plow parts are there. Okay, sir has dealt it in great detail in the lecture, I think. Just a second. Yes. This particular attachment is known as jointer. This particular attachment is known as coulter. One will cut the trash, and another one will remove the sticky soil. Okay, jointer and coulter. Why jointer is placed? In order to facilitate decrement in the draft. Okay, it will not. It will slightly increase the draft, as well as when the soil condition, soil will get stuck, and if it is not removed from time to time, then the operation, the functioning of the coulter will get hindered. That is why another thing is provided, which is known as jointer. Okay, see here the explanation is there. Jointer, it's a small plowshare that runs ahead of the main plow bottom. Its main purpose is to turn over a small strip of soil and bury the surface residue at the bottom of the furrow, and not to cut the furrow. Okay, its job is to just turn the furrow. Okay, and coulter is there. Okay, coulter is there. This is a disc shaped or a knife like attachment that cuts the soil vertically into the ground ahead of the plow bottom. It helps to create a clean and well defined furrow wall, and it can also sever through, or it can bear through a tough vegetation. Okay, and cutting edge is this particular edge. Okay, this particular edge is cutting edge, this one. Okay, cutting edge of the moldboard plow. Okay, this is there. Yes. Yes. Okay, this term refers to the sharp leading edge of the plowshare itself, and it's not a separate attachment. Therefore, coulter is the dedicated attachment for making initial vertical cut in the furrow slice. This is the explanation. Okay, I don't think you people must be having any doubt in this. Still, if you are having, then please do tell me. Okay, if it is clear, then please tell me that I am clear. We'll move forward. Okay. Meanwhile, a question for you: who created the first moldboard plow? Just for your own general knowledge. This question is clear, not clear? What happened? Everyone slept? Clear. Good. Good, good, good. Very good. And one bonus question is there. Okay. Or toughy question is there. Who created the first moldboard plow? Okay. In this form and manner. Not like that you will say that prehistoric humans, they created the first plow. So I am saying Neolithic humans. No, 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 no. I am want to ask you that who created this particular uh, moldboard plow in this form. Okay, this is a question from my side. Okay, try to search it. Okay, for you only. I am asking this question, and do tell me if you are familiar. Then tell me now, or else you can tell me in the next class. Okay. And hint I am giving you, a tractor, huge tractor company is there. Yes, yes, yes. John Deere. Yes, yes. Great, great. Huge tractor company is named in his name, in his name only. Okay. Great. John Deere. Yes. Now let us look at our next question, because you are clear. A rotavator is having 11 discs, okay, that operates at a forward speed of 4.5 kilometer per hour, okay. Each disc is having 4 blades in one plane and making 280 revolutions per minute. What would be the bite length of the rotavator? Okay. Just try to solve this question. If you don't know the formula, then the formula is this one: L equal to Vf by N or into N. Units you have to just see. Yes, Jefferson. Okay. The first commercial motor plow, I think, was made by John Deere himself only. Okay. Commercially, he was the pioneer in creating the moldboard plow in this form, okay, which I have shown you, according to my knowledge. Okay. If he was some another person, then you can please elaborate. I'll bear with your explanation, no problem. Yes, we have to focus in this question. Okay, byte length we have to calculate. I'm giving you 2 minutes time. Take out your calculators to try to calculate it. Okay, byte length formula is this one: Vf over n into n. Here Vf, what would be the Vf? Would be the forward velocity, n into n. Okay, n would be my RPM. Okay, and n would be my number of blades in one plane. So one data would be useless here. Whichever it is, you just eliminate. Okay, byte length of the rotavator. You just try to calculate it. Okay. Remember about the units. Okay, in most of the questions which I solve, I take SI units. Okay, or I keep the units of denominator and numerator the same, and I adjust LHS and RHS accordingly. Okay, so I don't go with the exact formula, but I try to maintain SI units, or I try to maintain the units in the same uh, uh, manner. Okay, this particular concept is very useful in gate examination. Okay, if your units are clear, then very easily you can sail through the gate examination. Okay, Varnika has solved and she is saying option B. Others, please do try to calculate. I am just coming in 2 minutes. Okay. Yes. B, A, B. Okay, two people have got B. Okay, great. Others, please do try to calculate. Here at IIT Kharagpur, we are having a HPC facility, which is known as Param Shakti. You just try to Google it. So actually what happens whenever we push a query in our this facility, then it gets processed through a high-end supercomputer. Okay. So after the query is resolved, we get a ping message. Then we have to submit another query. So that is why sometimes I get disturbances. Just for your own interest, I am telling you how we deal with supercomputers. Yes. BA. Okay. 4.07 into 10 power 3. Very nice. Muhammad is getting a huge success in option. Yeah. Muhammad, some different, some thing is wrong with the units, I think. That is why you are getting such a huge answer. 4017. What is the unit? Please do tell me. 4017 centimeters, millimeters. Yes. Some people are getting A, some people are getting B. Good. Means C and D won't be an option, mostly. Please do calculate it, okay? This type of question is very common in the examination, okay? Byte length, basic of rotavator design, dealt in lecture number 6 in our course, okay? Yes, how to substitute? Just wait for 1-2 minute, okay? I'll just tell you, okay? VF n over n. This is the formula. VF is the forward speed, okay? N, small n is there, okay? Number of blades in one plane, and n is your revolutions, okay? Revolutions per minute. Units must be same. This is the most important attribute, okay? Okay, let us move at the explanation, okay? Correct option, whomsoever answered B, they are absolutely correct. It is 6.7 centimeters. Okay, it is not 4.83. Okay, see here it is. I have explained you. Okay, VF over N into N. VF is the forward speed. Okay, units must be the same. Okay, N is the number of blades per disc. Okay, already I have told you, and N is the rotational speed. Okay, units must be the same. Okay, here I have taken VF. I have changed in centimeter per minute. Just see it, okay? And I cannot do anything about small n. It is 4 only, okay? 11 number of disc in the rotavator, that is of no use to us for calculating the byte length, okay? This capital N is 280 RPM, okay? 280 revolutions per minute. So the unit would of VF would be either meter per minute, okay, kilometer per minute, or anything which has having a minute in the numerator, okay, in the denominator, okay. So just go with it. L is VF over N over into N, okay. N is small n is unitless, okay, and capital N is having a unit RPM, means some number per minute, okay. And similar in the numerator, you are having meter per minute, kilometer per minute, or anything per divided by minute, okay. So ultimately uh, per minute will get cancelled in the numerator and denominator, and ultimately you will get the unit of length, okay. So here directly I have converted, okay, 4.5 kilometers per hour means 4.5 into 1000 meter per hour, okay. 4500 meters per hour, okay. That I have just divided by 60, okay. So that will be those many number of meters per minute, and then multiplied by 100, that will give you centimeter per minute, okay. Clear? Yes. Mohammed, are you getting now? You are getting 6.7 centimeter. Just do calculate, okay? Because two people have got the answer correctly. That is why I am confident that my calculation is also correct. Okay. Okay. Great. Okay. Okay. Great. 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 If anybody is having any doubt, then after the lecture, please do revisit through the notes. Okay. I'll put the notes in the Google Drive link. Okay. Yes. Let us move forward. The bearings on the gang of the disc harrow are subjected to Radial load, thrust load, both A and B, or none of the above. Okay. If you know that where bearings are there on a disc harrow, then you can very easily answer this question. Yes, Abhishek has answered both radial load and thrust load. Great. In this particular case, I already knew that some of you would get confused. That is why I have got an exploded view of a disc harrow. I'll show you. Okay. Thereby, immediately you can just see and tell that which load would be acting. Either it would be radial, either it would be thrust, or both, or none of the above. Okay. Do try to answer it first. Yes. Yes. Two people have answered at SC. Great. Both radial and thrust load. That is what you want to say. Okay, great. See, try to visualize. Okay, bearings are there in a disc harrow. Okay, radial load means the load which is acting along the radius, and thrust is generated by a rocket. Okay, it will try to push the entire bearing system perpendicular to the plane in which it is fitted. Okay, thrust means, just try to visualize, thrust is generated by the reaction force of the gases in a rocket. So how thrust acts, it propels the rocket in the upward direction. Similar to that only, that is known as thrust force. Okay, so thrust force is there. Okay, it will act in the plane perpendicular to the bearing system, and radial load, it will act along the radius. Okay, so radial load and thrust load, and whomsoever answered option number C, they are absolutely correct, both A and B. Okay, radial load, it will act along the perpendicular axis of the rotation of the bearing. Okay, radial load, why is it getting generated? It is getting generated due to the weight of the harrow, and thrust load acts along the line parallel to the axis of the rotation. Okay, rotational axis, and parallel to that. Okay, that would be your thrust load. If you want to just see it, see these pictures one by one. Okay, this particular thing, this is your bearing. Okay, this is what I am talking about. Okay, it is getting, this one is known as sleeve. Okay, this one is known as bearing, this one is known as sleeve, this one is known as cover. Okay, two particular sets of bearings I have deployed inside this cover. Okay, first figure number 1. Okay, just a second, it is getting saved for you only. Just a second. Now it will get fitted. Okay, this particular system will fit inside one another, and then this particular system, this one, will go inside my disc harrow. Okay, this is the thing. So here, which force will act? Both the forces, radial as well as thrust load, will act. One will try to throw the entire bearing out of the plane, and another one will act force in the plane perpendicular or parallel to the, not in perpendicular, parallel to the plane of the bearing. Okay, this is the final assembly. Okay, final assembly here I have drawn. See, that bearing is fitted at this end. Okay, I knew that some of you won't be able to visualize it. That is why I have got the exploded view of the entire disc harrow, so you can better visualize the things. Okay, this is the thing. So both the thrust load as well as the radial load would be acting. One will try to throw this entire system which I have encircled. It will try to throw the system outwards, and another thing would be, it will, another force would be acting, which will try to act in the parallel plane. Okay, it will try to throw the bearing system outwards in a circular manner. Okay, this is the thing. Both the radial load as well as the thrust load would be acting. Okay, clear? Clear, not clear? What happened? Views are clear? Everything is clear, not clear? What happened? Any doubts? Anybody? Clear, great. Okay, good, very good. If it is clear, then we will move forward. Okay, yes. Anybody having any doubts anytime, you can please do ask me. Okay. Yes. A tandem disc type disc harrow, that one which I showed you in the question before, with 14 discs of diameter 520 mm. Disc spacing is 180 mm, is operating in a field. If the gang angle is 30 degree, then the total working width of the disc harrow, it would be what? Okay, just try to use this particular formula, fit everything accordingly, then get the answer and tell me what is the answer. Okay. Yes. Hmm. See, good. 3.02 meters, great. Just try to substitute the values in this formula and get the answer. Anybody except Varnika? Could you please explain how to solve step by step, sir? Yes, I will explain you how to solve step by step. First, two steps are there. First step is this formula. Second step is value putting. Okay, two steps are there. First step I have told you. If you want to know how we get this formula, then go through the lectures. Okay, there sir has told in great detail how we got this formula. This is an empirical formula. Okay, so much explanation here I cannot provide you. Okay, regarding how we achieved it. We achieved it through experiments only. Okay, that is the this thing. Okay, if you want to empirically solve it, I can show you the procedure for that also. Okay, this also works. Okay, but you will not get the same answer. That is the thing. Okay, try to draw the arrow after this class, then try to make a gang angle, then try to do the calculation accordingly and try to get. But if the empirical formula is available, no need to put much stress about the geometry also. Okay, so two steps are there. I'll show you in the next slide, but I want you to try first. Okay. Okay. Yes. Okay. 3.018 centimeters and meters. Yes. Exactly what this is what I also got it. See, I will also show you my answer. I think you can see it or not. You will see it in reverse. I think I am good because it is a camera. Yes. Great. We both are getting the same values. It is nice. Okay, let us move at the explanation. Yes, 3.02 meters or 3.018 meters. That is the correct answer. Okay. Yes, step by step explanation is this one. This is the formula, and in the second step, we have put the values. Value putting, answer getting, and you would get the same thing like me. I am also getting. Sometimes, in order to encourage you, I have to also do the question twice or thrice. Okay. I already did it beforehand coming to the class, but I did it right now only. Okay, this type of question is very easy. So for three types of arrows, empirical formula are available. Do remember them and try to put the values and get the answer. Since the denominator is in the thousand, then absolutely the S and D would be in mm only. That is why we are dividing it by 1000 to get the answer in meters. Okay. In empirical formulas, you don't play with the units. Okay, we play in the with the units in which no constants are present, like 0.95, 1.2, 1000. Nothing is present. Then we can play with the units. Like in previous question, I showed you we have over n into n. Okay, in that particular question, we can play with the units. Okay. Is it clear? Maruti Kumar, is it clear to you? Not clear? Still want an explanation? Okay, clear, great. Yes. Okay, if you want an explanation regarding tandem type disk arrow, I'll just tell you it in short, no problem. This is the slide. Okay, types of disk arrow. Here I have shown you single acting disk arrow, first option, first figure. Okay, then offset disk arrow, or and the second figure and the third figure in the right hand side. This is tandem or offset disk arrow. What is the difference? Difference is between the gang angle, the angle the gang makes with the vertical. Okay, this particular gang angle, that is different in all the cases, as well as the arrangement of the gangs. Okay, if one particular gang is there at a certain angle, it is single acting. If two are there in one line only, it is offset. And in case of tandem or double offset disk, these two arrangements in the C figure, here I have placed one over another to throw the soil in all the directions uniformly. That is known as tandem disk arrow. Okay, just go through the slides once more. Everything is written here. Okay, I have just explained multiple times also. Okay, yes, clear. Yes, okay, let us move forward with one more numerical question and the last numerical question for the day. After that, you can enjoy the rest of your day. Okay, a tractor drawn rotavator is operating at a speed of 4.3 kilometer per hour, and actual field capacity of the rotavator is 0.3 hectare per hour at a field efficiency is, and the field efficiency is 70%. Calculate the number of discs on the rotor if the spacing between two consecutive discs is 20 centimeters. It would be 5, 7, 9, 11. Okay, just try to answer it. This numerical is based on, it is somewhat like quantitative aptitude. Even if you don't know any formula, but you know the relation between actual field capacity and theoretical field capacity, still you can answer this question. Procedure I am telling you, hint I will give you. Okay. See, actual field capacity is there. Theoretical field capacity can be calculated. If theoretical field capacity can be calculated, then the width of the implement can be calculated. If the width of the implement can be calculated, then the spacing between two disks is known. Then number of disks can be calculated. Okay. Try to answer it, solve it. Okay. I'm here for you. I'll explain each and every step. Okay. But first you should try, because in the examination you have to play the ball first. Yes, Varnika has answered 5. Okay, great. In the examination, you have to play the ball. I have played the ball and reached at this stage. I don't play with the questions now. Okay. Okay, 9. Great. C, good. 5 and 9 option. Okay, great. We'll see what we'll get. Directly from the formula also, I think you can get. I told you step by step empirically, so that you, even if you don't know the steps, still you can do it. Okay. Good. Okay. Anybody else would like to answer? Please do solve it, okay? All the questions after the class is over are uploaded in the Google Drive, okay? Please do solve the numerical questions at least, okay? Yes. Anybody else? Please do solve it. Try to solve it. I told you the procedure also, okay? TFC equal to AFC, okay? Into I do not understand this question. Good. Now let me explain it, okay? Just a second. Correct option would be 5, not 9, okay? Yes. First of all, just try to follow this procedure. This is an empirical procedure, okay? No formula, nothing required, okay? First of all, what I will try to do, forget about the speed. I know actual field capacity given in the question. Field efficiency is given in the question, okay? Then theoretical field capacity that I'll calculate by using the formula theoretical field capacity. What it is? Actual field capacity divided by field efficiency. Okay. Or you can say that field efficiency into theoretical field capacity is actual field capacity. Okay. For you people, I just wanted you to try it first. I'll explain at the end of the question. Okay. Don't worry about it. Okay. Yes. Theoretical field capacity, first I have calculated. Okay. I am talking from step number 2 only. Okay. Just bear with me. Then theoretical field capacity, I'll try to have it in the same unit. Okay. So here I have used the unit as meter and minute. Okay. So just try to convert it. Theoretical field capacity. 1 hectare is 10 to the power 4 meter square. Okay. Similarly, 0.4286 I am getting 0.4286 multiplied by 10,000 4286 meter square per hour. Okay. In per minute, I'll divide it by 60. Okay. Then I'll get the TFC in meter square per minute. Okay. Then TFC is S into W. Okay. Speed multiplied by width. Okay. So the TFC unit is meter square per minute. So speed of should be in meter per minute. Okay. Then only unit would get balanced. Meter into meter per minute will give me meter square per minute. Okay. I'll just write it. Okay. Just a second. See, every time units are balanced. Okay. In our this type of questions, meter square per minute. Okay. It should be equal to meter multiplied by meter per minute. Okay. So from here, what I am getting? Width. Okay. Implement width. If I'll get, then I know what is the number of disk. Okay. Since I am giving disk spacing, okay, disk spacing is 0.2 meter and width of the implement I have calculated as 1. So 1 upon 0.2 is 5. Okay. So correct option would be 5. Varnika has answered it correctly. Okay. Except her, nobody has answered it correctly. Okay. Try to look at the explanation. Yes. Good. If you understood it, fine. If you want to repeat, me to repeat, I'll repeat it also. Okay. Just go through the explanation once more. You will be able to get it. Okay. Harish, understood? Okay. Good. Great. If you understood it, fine. Go through the explanation once more. I think that you don't get the didn't got the question in the very first attempt, no problem. Okay. After the explanation, I think it would have been clear to you and others also. Okay. If you want me to repeat once more, then please tell me. I'll repeat it also. Okay. It's a very easy question. Okay. Not too much difficult. Just you have to bear with what is being asked and what has to be answered. Okay. Try to do the question calculations once yourself also. Okay. Might be that you would be getting some different result. Okay. Yes. 71.43 when divided by 71.67. It would be in decimals. I have rounded it up to 1 meters. Okay. Width of the implement, it is generally in whole numbers. That is why I rounded it to 1 meter. Okay. If not, then I can round off in n directly. 4.99 something I'll round off it to 5 because 4.9 number of discs is not possible. Okay. So this is the thing. Okay. Any doubts, anybody? If you are having any doubts in this question, earlier questions, if you are clear, then tell me clear. Okay. This one is the last question for the day. I'll save the presentation in the Google Drive link. Okay. Okay. Yes, Varnika is saying
Yes, clear.
A. Okay, good. Thank you. Same type of sum has been given in lecture, sir. I get the answer as 4, but it is 12 in the video. Okay. Okay. I'll see to it. If you are the units are exactly same. If you are getting it as 4, then it would be correct, I think. No, it won't be there. I think 4 into 3. 3 number of something would be there. Okay. Just go through the question. In the next class, try to bring the question, then I'll be able to tell you. Okay. Yes. I've not gone through the question. Okay. Try to bring the question, then I'll be able to tell you that whether the explanation in the lecture is correct or this is correct. Yes. Sir, can you explain line of pull and line of draft? Okay, great. What is draft? Draft is the horizontal component of pull only. Okay. Speed 4.5 kilometers per hour. Yes, it is 4.3 kilometers per hour in this question. I think you are talking about the question in the lecture. Okay. Yes, I was explaining you regarding line of pull and draft. Draft is the horizontal component of pull only. Okay. Yes, line of pull. Okay. Suppose I am in the next class, I'll try to bring the entire diagram to you. Okay. Till this point of time, just try to focus on what I'm saying. Okay. Suppose a single tool is acting on a soil. Okay. Single tool. Okay. A pointed tool is acting and it is being pulled in the soil. Okay. So at the contact point in of the penetrating tool, okay, and the soil, there would be maximum amount of friction. Okay, that point we generally call as center of resistance for a single tool. Okay, single tool, single knife. Okay, I'm talking about. Okay, that is known as center of resistance at the contact point in which the implement, not the implement, center of resistance for a tool or a cutting tool and an implement would be totally different. Okay, the center of resistance of that particular tool or that particular implement or that particular cutting tool, okay, that would be at the point at which it is entering the soil and at which it enters the soil. Okay, try to visualize it, and it just the friction, it tries to overcome the friction. That would be center of resistance for that particular knife or that particular tool. Okay, and horizontal component of pull is known as draft. Okay, what is I told you about the center of resistance. From the center of resistance, just try to draw a line till the point at which I am trying to pull. I'll be pulling the tool. Suppose this is the tool. Okay, I'll just draw it for you. This is the tool. Okay, this is the soil. Okay, so I'll be just trying to pull this knife. Okay, or this particular implement. Okay, in this particular direction. Okay, in the horizontal direction. So this particular point would be my center of resistance, and from that point, okay, this particular point, if I'm trying to drag this particular knife in the soil, then join these 2 points, center of resistance and center of pull, I'll getting the line of pull. Okay, this one will be my line of pull. Okay, and horizontal component of this particular pull, okay, in the direction of the travel is known as draft. Okay, got it? Line of pull and draft. Yes. Did you get it? Okay, good. In the next class, I'll try to bring two things. First one was that dead furrow and that back furrow thing, and your this doubt. Okay, line of pull and line of draft. I'll try to bring the whole figure. Then I'll try to explain you through the figure. You will get a clear picture. Okay. Yes. Speed 4.5 kilometer per hour. AFC is 0.24. Yes. Efficiency is 76% and spacing is 20 centimeters. Okay, these were values. Good. I'll just calculate it using the same method. Use this particular method instead of 4.3. What answer you are getting? Just tell me. 3.5, sir. So confused. I rounded to 4. Okay, I'll just calculate. Just 1 second. Yes, it is coming 3.5 only. I have also calculated using the same methodology. It would be 4 only. Great. There might be some mistake in the calculation. According to the data which you have provided, it is coming 3.5 only. I showed you, I calculated in front of you only. Okay. It is coming 3.5 only. Okay. Yes. Okay. Thank you, everyone. If still you are having any doubt, then please do tell me. I'm making a note of that. Okay. Please do tell me. This is the class from my side. Okay. Still you are having any doubt, then you can please ask me. If you are not having any doubt, then please you can kindly leave. Okay. Class is over from my side. Okay. I am open to discussion from you people. Okay. Any feedback if you want to provide, then you can please provide. Okay. Else you can leave. No problem. Okay. Thank you. Thank you, everyone. Great. Thank you all. Okay. Thank you. Thank you, everyone. Okay. If no doubt is there, I am ending the session for all. Okay. Thank you, everyone, for joining. Okay.